Dazzling, legendary, the most beautiful planet in the night sky. But secretive Saturn has been holding out on us.
We've learned a vast amount about it, and most of this has been very surprising.
We thought we knew those bodies. We had no idea.
Saturn boils with extreme weather and weird lights. The rings ripple and twist, bullied by over 60 remarkable moons.
They are individual worlds. They each have a story to tell. This is a planetary explorer's dream.
Saturn's moons are the hottest property in the search for alien life.
If there's one place in the solar system I would put a bet that life exists there right now, I would choose Saturn.
And on Saturn's largest moon, we may have already found it.
We have found some curious things on Titan, and it might just be evidence of life.
Saturn, the jewel of the night sky, dazzles with its beauty and scale. It's huge, so big you could fit more than 700 Earths inside it. But don't let size fool you.
One of the more interesting things about Saturn is that it is so big compared to how much stuff is in it that it's actually lower density than water. The old joke is that if you could find a bathtub big enough and fill it with water, Saturn would float, but it would leave a ring.
Other planets have rings, but none so vast and glorious as Saturn's. The journey from the outside of the main rings to the inside edge is 66,000 miles. Yet this vast collection of dust and ice particles is whisper thin, just tens of feet in places.
Saturn's rings are made up of mostly very small particles of ice and rock. Some of the particles are larger, but for the most part, no bigger than grains of dust.
Racing within the rings and orbiting far outside them are over 60 moons made from rock and water ice. They range in size from tiny snowballs to worlds with active geology, liquid water, weather systems, and possibly even life 1 billion miles from the warmth of the sun.
It's so cold out there. We just thought there'd be nothing there, and we were so wrong. We were so wrong.
Saturn's first shocker, its wild weather.
The storms on Saturn are extremely violent, unlike anything we see on the planet Earth. In fact, Saturn has the second fastest winds in the entire solar system.
These winds race through Saturn's cloud tops at over 1,000 miles per hour, 4 times faster than Earth's strongest cyclones. And lightning bolts flash up to 10,000 times more powerfully than those on Earth.
Everything on Saturn is just so very, very much bigger. I mean, there are weather systems that are as big or bigger than the Earth.
Saturn's ferocious weather is surprising because on Earth, weather is driven by the heat of the sun. It causes the seas to evaporate, creating clouds and rain. Saturn lies too far from the sun to feel the same warmth, so the heat that drives its weather must be coming from somewhere else. To understand this mysterious heat source, we need to go back 4.5 billion years to the birth of the ringed planet. The planets of our solar system emerged from a vast swirling cloud of ice, dust, and gas. The same ingredients can still be found on Earth today in places like Iceland, where volcanic ash mixes with icy glaciers.
So if you want to build a giant planet like Saturn, this pile of raw material here is a great visual analog. There's a lot of oxygen and hydrogen in the universe. That makes water ice. And the stuff initially that made the solar system is basically this stuff here. It's dirty ice, water ice, with a little bit of rocky and metallic minerals left in there out there in the cold of space.
4.5 billion years ago, a vast cloud of dirty ice particles, shrouded in hydrogen and helium, collapses under its own gravity. And at the center, a new star, our sun, sparks into life. The heat of the new star melts the ice closest to it and blows away the gas, leaving only rocky debris behind. But farther out, icy material and gas survive. A boundary forms, a frost line between the rocky inner cloud and the icy gas beyond.
Once you fired up that campfire, if you will, what will be left behind in the inner solar system is going to be this stuff, the silicate minerals you make a planet like the Earth from. But far away from the sun, where it's colder, you cross the frost line, and what's out there is still cold enough to maintain the ice behind, and there's a lot of it there. At first you make a sort of a solid core of this material, but when you reach a critical mass, you've got enough gravitational influence to start to directly draw in some of the hydrogen and helium in the interplanetary cloud.
Saturn's huge solid core, now 10 to 20 times the size of Earth, generates relentless gravity and draws in gas. The bigger this gas ball gets, the more material it sucks in. Saturn's massive gravity then gets to work on its fledgling atmosphere, compressing it. And like any gas under pressure, it gets seriously hot. Even today, Saturn's high-pressure atmosphere heats its core to 21,000 degrees, twice the temperature of the surface of the sun. And it's this heat rising up which forms Saturn's distinctive bands and drives its extreme weather.
Saturn's actually rotating very quickly. It's a large planet. It rotates once on its axis about every 10 hours. So as the weather comes up from the interior, it gets smeared out into bands.
And at Saturn's North Pole, the bands do something that at first glance seems impossible.
There is a gigantic vortex, a spinning region of air that's shaped like a perfect hexagon.
You have waves of pressure, density, and temperature that start to interact with each other. And these waves can actually interfere and become one big wave that goes all the way around the planet.
This giant wave settles into a long-lasting pattern because there's no rocky surface below to disrupt the winds that form it.
They form a beautifully defined regular hexagon. It's one of the most spectacular things about Saturn.
Imagine Saturn without its rings. Just a pale globe floating in the darkness of space. With the rings, it's magical.
Undoubtedly, the one thing that captures everyone about Saturn is the rings. It's inspired fiction stories, and it's inspired everyone who's looked at it in the night sky.
When I was 4 or 5 years old, my parents bought a small department store telescope. And I remember looking down into that eyepiece and seeing this perfect jewel of a planet.
There's just nothing better than this. And you can just see the rings going around the planet just perfectly. They're just a gorgeous elliptical racetrack.
From the eyepiece of a small telescope, the rings seem quiet and serene. But up close, it's a very different picture. We know this thanks to a space probe called Cassini and over 10 years of images like these. Ice particles jostle for position like stock cars, traveling inside the rings at hundreds of thousands of miles per hour. These particles range in size from chunks of ice as big as houses to the finest powder snow.
It wasn't until we went to Saturn and stayed there with Cassini that we learned just how fiercely complex it is. you have the gravity of the planet itself and all of these moons interacting with the rings and the moons and the planet. All of these things are sculpting that entire system on scales that are both subtle and gross, and it makes this magnificent crown jewel of the solar system.
As small moons go around inside, the ring particles dance around them in response. We see areas of the rings that get raised up as a moon goes by. Moons will even switch orbits with each other. So there's a lot of dynamic stuff going on inside the rings.
Scientists believe that from time to time, Saturn's icy moons break up, adding new material to the rings. This means that the structure of the rings is constantly evolving. With Cassini, scientists can deconstruct the physics of this evolution, and it's teaching us the rules that make the whole universe tick.